Hi, Rick.
Hello. All right.
So how do you want to do this?
Let's let's just give it another minute.
Okay.
I think we're good. We're good. All right, folks. We literally have 1 hour, I think it is. Got to check the schedule. 4:30, 5:30. Yes, we have 1 hour to come up with the most transformative, groundbreaking recommendations that the world has ever seen. So, I have a few ideas. I'm sure others have ideas. Um, and we heard a lot of different things. Um, does anybody want to start, or do you want me to just throw some things against the wall?
Rick, can you frame the discussion a bit? Like, what's the broad, the
Oh,
breadth, what's the scope?
okay. So think of it this way. The meeting is about lung cancer, quantitative lung cancer screening. So growth is the main right now designator of whether somebody has cancer or not. And we also cover the other diseases, COPD and cardiac diseases. So what we try and do every year, there's kind of two things that go on. One is that we don't want this to just be a meeting. For 20 years, we said, we don't want this to be a meeting where we come together, we give a few talks, and then next time we actually talk again would be a year later. What we try and do is come up with recommendations that in many cases with a little bit of work might require some collaboration, it might require some gathering data, might require some printing out some new objects for scanning. We actually learn something across the coming year. The other thing we want to do with recommendations is to put a statement out saying that something is important, because we want to change how we go about doing that thing. So we've always said the data, collecting large, diverse databases is a huge priority. For 20 years, we've said that. And we've made some progress on those things. So we have the opportunity here to make any type of recommendation that we feel would do the biggest, make the biggest advance, or help make the biggest advance within the next year or a couple of years. And one more thing. Every year we write up the meeting, including the recommendations, into a publication. So it's not just us talking to ourselves, but we actually do a fairly good job of getting those publications out there, and then referencing them as we all write our next papers and things as it's appropriate. Does that answer the question?
Yeah, that's very helpful. Thank you.
And indeed, I don't know if I'm sharing my screen, but we had a few questions we put together for the panel, for the breakout, to address. A little bit as a guiding. I don't know, is this coming through? I'm sharing my screen, but I don't think I'm seeing anything. Maybe, I don't know if someone from Blue Ridge could help us.
No,
Yeah.
we can see your screen, and
you can. Okay,
generally speaking, questions are usually thought provokers.
Absolutely.
So what we want to do, yeah, we can ask the questions, we can discuss them, but in the end of the day, we have to start writing up some impactful recommendations. Go ahead. Oh, so Raul is co-moderator on this. So thank you, Raul.
So again, I don't know if we want to, as a starter, try to use these bullet points as a thought-provoking, as you said, element. No, so from there we can obviously go wherever the conversation takes us. No, I think after the great session we had a few minutes ago, I think we touched upon these elements.
Raul, do you want to cherry pick one or two? Let's say your favorite question.
Well, I mean, all of them are favorites. No, I think the future is intriguing, and everybody's very excited about photon counting and so on. But before that, I think there is now an ongoing document, and maybe you, Rick, can talk more about it, about a joint protocol for lung cancer screening and COPD and what it means. No, and I think there is many of the driving elements for that document revolves around optimization of imaging, both in terms of quality, resolution, characteristics for multiple entities, densitometry, sizing, metrology. So I'm wondering if, what is the general sentiment about how we can optimize our imaging protocols for a multi-parametric, so to speak, assessment of chronic and acute lung diseases, including, I guess, or smoking-related lung diseases. So I think, to me, probably this is it will be a great starting point, as a group to discuss that. What are the driving elements or what are the key elements that we should take into account for imaging optimization under this kind of overarching mission, that is, in my opinion, this multi-parametric assessment of lung disease.
Yeah, so I can give more context. I showed it in my talk, but one of my talks, but we basically came together during COVID, and we said let's get some guidance out there, because we need to learn as much as possible about quantifying COVID. So it was really wonderful. Lots of really great international thought leaders came together, and we created a guidance document that said what we think would be the way you should scan COVID. And we leveraged what we knew about lung nodules and what we knew had been studying about lung density. So that wound up being a really important publication. And we actually did something which I think is kind of new, which is we as a group came together and said, we've had no luck asking the scanner manufacturers to give us quantitative reconstruction kernels. So we're just going to say which kernels we think are the most relevant, most important for quantitative imaging. And we're going to tell the scanner manufacturers which ones we're relying on. And that worked out really well. So now we have a set of kernels. All of them were checked with the scanner manufacturers. So we're now all on the same page. Everyone seems to be happy with that. And but it doesn't take into account as much iterative and now AI algorithms. So anyway, that's the background. We're well on our way to creating that manuscript, and that was a recommendation in the past. So we're making good on that. So I think we're in good shape. The one thing that we're missing, which people is obviously can point out, is that we're creating right now a combined guidance document for acquiring both lung cancer screens and emphysema. And one could argue, well, why not go the whole way and do lung cancer, emphysema, and cardiac calcifications and cardiac disease. So that could be a recommendation that we make. I'll just throw it out there. We accelerate and go quicker toward cardiac, including cardiac, into a combined protocol. What do you guys think?
I definitely agree that like the multiple screening is a great idea, right? Combining multiple exams in one. Maybe if you talk about selecting a kernel, that's assuming you have an existing scanner and everything is existing. Then the best you can do is just choose one of the existing kernels. But in the end, is that a trade-off between resolution, noise, and dose? And if you have the flexibility to optimize everything, then you would try to design for reaching the desired resolution while minimizing the noise and the dose, right? So,
well, actually, I have another way of looking at it, which is get as high a resolution as you can that doesn't get completely overwhelmed by noise. So achieve a certain signal to noise value with a low dose, okay? And then software post-processing can throw away resolution, you know, and trade it off. So we don't have to.
But it's dose dependent. So then what's the dose level you use?
And that's going to be machine and patient basically dependent, but in general, you know, lung cancer screening has been operating around 1 millisievert effective dose, right, or below, and some people have been pushing it as far as half a millisievert. Problem I have is that a lot of scanners trade off.
Rick, you're breaking up.
The problem is that some scanners will trade off resolution for noise. So, if you try to, I'm sorry, as you lower dose, it'll give up resolution to try and keep noise in check. So you have to be very careful with these things, and that's why we strongly encourage people to use phantoms to see what their scanner is actually doing under these conditions.
Too much marks in the scanner, yeah. I thought the cardiac reporting was part of the lung cancer screening protocol anyway.
What reporting?
Cardiac, that observation that was reporting back on coronary arteries was a standard part of.
But we're not necessarily using the best. We're not necessarily using the best image acquisition protocol for that, right?
Not sure what wiggle room you've got with a whole chest lung cancer screening low dose scan. I mean, other than to avoid the lowest possible doses, you're not going to gate.
There are a lot of things that you have to watch out for. So, do you remember the slide I showed with the different slice thicknesses and it changing from isocenter out to periphery? Remember that?
Yeah.
Well, if you could imagine, some scanners actually get much higher resolution at the center than they do out at the outer edge, and the nominal slice thickness that was being requested is only attained at around 100 millimeters or so. So what that means is that the center of the scanner is going to have gaps. It's going to have it's going to be undersampled for the resolution that you have there. And
the center.
Yeah, that's where I'm going. So I'm not just saying it's theoretically possible. I'm saying we've seen it. Okay. So the question is, if you do a lung cancer screen and you get one of these acquisitions where you've got much higher resolution in the center and degraded off much worse at the outer sides, you could run into a problem with your sampling for cardiac calcification. So
that's in the sweet spot.
That's in the sweet spot. You would think the center would always be great, but it's not necessarily. I mean, you got to really think about it from a signal processing point of view. Anyway,
I think another topic on top of the kernel selection and thinking of a joint protocol specific for densitometry, that is key in COPD or emphysema-based assessment, is also the issue of a calibration or biases in the density measurement across scanners, and has been well characterized and reported. The differences in air compartments in the trachea, not due to the underlying being hardening, that is body size dependent, So I think, I don't know, Rick, is this something, I mean, what are the opportunities, for improving both quality assurance and quality and potentially phantom-based corrections for that problem? Because I think it's becoming more and more apparent that is an issue if you want, for example, to use lung cancer CT screening to track progression of emphysema. But it's a great opportunity there, as there is interval scanning. I mean, I don't think we have emphasized that, in my opinion, enough, but that's kind of a...
So I was going to make a recommendation to consider for our group. Right now, we have very large numbers of clinical, FDA-approved clinical applications, like lung nodule volume, for example. And the requirements on proving that lung nodule volume system works well are, they're very shallow. Those requirements are very easy to meet. But what we can do with all the calibration work we've done over the last 20 years is start to propose that software has bounds on image quality. And if it were up to me, those bounds should be physics-based. Those should be fundamental properties like resolution, noise, sampling rate, spatial warping, things like that, edge enhancement. So one unmet opportunity is to potentially meet with regulatory bodies, bring together regulatory bodies from around the world, and start to make the case that software needs to define what range of quality it can safely operate on for let's say a given clinical task. What do you guys think about that?
I mean, what are you thinking? The software would do an analysis of some kind of phantom scan, or what?
You would simply validate that the protocol passes the quality requirements for the software, right? So we already have quality. We already have phantoms. We already have quality metrics. Okay, fundamental quality metrics that are very easy to get hold of, very low cost, etc. Why not say, hey, if you're going to measure 6 to 10 millimeter lung nodules, the volume, and you're going to try and do volume change, you better have at least the KIBA requirements, which we've defined as the size of the point spread function, for example, and other things. And it has to be within a certain range, or the software isn't guaranteed to work. Isn't not guaranteed, but it has no chance, actually.
Yeah, I had an alternative thought that what you could do is say the software is designed for this scanner with this protocol. And this protocol is defined because of, this is a lung cancer screening protocol that we have reviewed, and it has these parameters for every aspect. So if we, instead of saying your software has to have these things, it might be more productive to say, if you're doing lung cancer screening, use this protocol, and this protocol has been certified for this scanner with the following parameters.
That only works if the manufacturer agrees not to change that protocol. And
defines what protocol they use, or is that?
Somebody could correct me if they want to, but I've personally seen scanners not pass certain quality checks.
Yeah.
Then the manufacturer coming in changes something,
The software,
and then magically now it's passing.
Passing.
Like,
Yeah, but I will disentangle the reconstruction software and everything that goes along, and that is what I was bringing the whole issue about being hardening and bias, systemic bias in the signal from the protocol, that is basically the params you select to try to harmonize the imaging for a specific use case. So I agree with you, Rick, that I think on this topic, I feel on this notion of a recommendation is that we need to define a quality for a given task. We will define a quality range, and then the software has to describe that. And then imagers or the systems will have to prove they meet that requirement. I think that is valid for the software piece, but I think the protocol is something that is heavily human dependent, meaning that technologies can modify that protocol based on the clinical practice of that specific place. So that is what I think is.
But we don't have to solve everything here on this call.
Yeah,
we can make the recommendation that this is an important area. It deserves additional discussion, analysis, meeting, potentially with regulatory bodies, potentially with ourselves. And we could resolve the technical specifics at those additional meetings. We don't have to solve it here.
No, I agree, and maybe I was agreeing with you that I think a good approach is defining that range. Then a different story is how you meet that range. Maybe as a recommendation or follow-up recommendation, in my opinion, is that I think we can split this problem in one, protocol harmonization, for which I think we put a lot of emphasis. The other approach that is more emerging, and obviously there is no final solutions, but I think is worthwhile entertaining from a recommendation standpoint, is the opportunities around post-reconstruction harmonization that are emerging from, driven by AI. And we have seen all these techniques around generative AI that they promise to go from low dose to high dose. And obviously, although that is still, I want to say, is still in a proof of concept stage, I think creates an interesting paradigm. So again, I don't know if I agree with your recommendation. I will on top add the notion of we need to do qualified protocols for given tasks, and then potentially harmonize, because something that I think will not achieve with the protocols is the fact that vendors are different, and vendors obviously they achieve their advantage or competitive advantage edge by having proprietary technology that obviously is not fair to share. So I feel the only way to even the play field today from a quantitative imaging standpoint is by potentially putting in place some of these harmonization techniques, or at least opening the door for more research in that domain. Because maybe I'm speaking with my own biases around what is happening today in densitometry and the assessment of emphysema, but we see that even scanners that are well calibrated, they exhibit different levels of air within known compartments. And that has been obviously an Achilles heel. And that Achilles heel, to some degree, could be somehow resolved with sort of a post-harmonization technique, that obviously takes into account the population rather than each scanner individually. So again, I don't know what the panel or everybody might think on this. Like I feel there is like 3 tiers: the software that is vendor controlled, the protocol that I think is controlled by multiple stakeholders, where Kiva I think has done a phenomenal job, and then the opportunity around harmonization techniques that will try to create this, how to say, democratizing, the image quality across multiple vendors, if you will, using advanced techniques.
So, I mean, what you said sounds reasonable, but I have to really think about that a lot more as a way of breaking it down. I I have a slide I tried to put together. Who's sharing? I'm not allowed to share. Okay.
I can stop. I stop now.
Oh, okay. So I put three things down. We don't have to use them. We can throw them all out. But the first one we discussed earlier, potentially adding cardiac to an optimal imaging protocol guidance. Seems like a no-brainer.
That's a no-brainer to me.
What's that?
That's a no-brainer to me. Add the cardiac, sure. I thought it was already there and a few other things, but
we started with lung cancer and emphysema, really.
Right. But
how do you feel, Raul, about wall thickness stuff? Is that important enough to get in there?
No, I think it's important. Maybe I think it's important, although, thinking of the work that Kiva has done, we don't have I think we don't have a well-established biomarker for airway disease at large, At least in pure inspiratory scans. I think there is interesting research looking at airway wall thickening in different ways, but there is not a concrete way, at least with the same evidence we have for emphysema. So that is probably my only comment, although I can see how it aligns much better that problem with the lung cancer challenges than any other problem.
Okay, well, why don't I just put it like I've written it here? Do you guys agree with that wording?
Like cardiac calcium scoring?
Yeah, we could make it CAC.
Because I know that in cardiac, people are starting to think more and more about doing screening with contrast, right? Which is not what.
No. Since we're already starting with a low dose lung cancer screen,
yes,
we're not going to be discussing.
Yeah.
No. I was just thinking with wall thickness, it's a big challenge to come up with protocol requirements. I mean, at what level, what depth of wall, thickness are you talking about? Major arteries and how far out and all that kind of stuff, which seems a little not so well defined right now.
Again, we don't have to solve the problem. This is a high-level recommendation to say, hey, we think we should add, for example, coronary artery calcification to our protocol guidance. And we're already considering wall thickness right now, right, in our group. So, by the way, Tony, if you want to join the group, just let me know. We meet every month.
Which group?
It's a group of people that come together once per month to come up with this optimal. It's essentially a document. For lung cancer screening and emphysema measurement. So anyway, I'll just invite you. Okay, so this first one is pretty much a no-brainer. Everybody agrees with that? Is that fair?
Yeah.
I'm leading the witness. I'm so sorry. No, seriously.
It is good. Yeah, I agree on that.
Have we reached too far? Okay. So the next one, additional study data collaboration on deep learning AI reconstruction. And I haven't given any specifics. I'm just saying, based on our discussion earlier today, it seems like there were more questions than answers, and we got a lot of work to do.
You
Bruno,
talking raw data here?
I'm talking about anything that will help, even if we have a few, let's say, 3D printed new objects that we can use for study. I don't know, Bruno, do you feel this would help you and GE?
So I think I like what Raul was saying about distinguishing what's the best protocol, which is like your first bullet. And then the second bullet is more like the scanner design, the scanner software. This actually falls under that, right? So so we could think about what are the biggest things we want from the scanner, which you're not going to get tomorrow, but maybe 3 years from now. That would be very useful to understand what the biggest needs are from a scanner perspective. For example, it could be motion compensation or better spatial resolution or whatever it might be. But and then maybe the third aspect could be what about testing, validating whether whatever your scanner is, whatever your protocol is, test phantoms or tests that establish, does it reach the desired performance?
Yeah, and this doesn't try to break it down. This just says, hey, we should be meeting more often on these things and collaborating more, because what we don't want to do is like find ourselves 2 years from now not having really done much about it, and then it's in the field and we're trying to figure out, how do we handle whatever it is.
Okay.
I think that is. Oh, sorry, Bruno. Go ahead.
No, go ahead.
No, I mean, on this topic, on the deep learning AI reconstruction, and maybe it's a question for the group, I totally agree that I think we need, additional studies, data, collaboration, potentially governance, no? Because there is a big topic in general in AI, not thinking of the generative elements and how you govern, for example, that there is no artifactual, things that are introduced. But on that topic, and maybe bringing things a little bit more closer to our core interest of things where we can provide recommendations, to me, one primary question is a phantom good enough to evaluate the new generation of AI-based reconstructions versus the prior generation where we maybe thought or believed that can be done that way? No, and I'm saying this because we saw kind of the in-between was, model-based or the different generations of iterative reconstruction, where we saw the phantom fully capture that. So you truly need to test the method against the object that it will be indeed image, no?
No, we have never purely relied on phantoms for understanding it. We use clinical data, phantoms, and even simulated data.
Yeah.
So that's I would change what you said to say, we always use multiple sources of data to evaluate the performance of reconstruction.
I totally agree, and I like you to saying that. But should we be very vocal in that recommendation? No, we need a multi-pronged, multifactorial, you might call it different ways, no, multi-axis evaluation approach, no, that relies on these elements. No, I think to me that is key, no, at least to put that piece in mind, no.
But even before we get to validation, we could be developing some test objects, test data for development, right?
Yep.
Absolutely. No, I absolutely.
How does AI differ from a traditional in the sense that the goal is the same, is to validate the measurement properties of the scan. So other than
so
the
I think,
putting a guy.
yeah, I think the original reconstruction, linear reconstruction, there everything could be captured by an MTF and a noise level. And as your reconstruction becomes more nonlinear, with AI being extremely nonlinear, it becomes very important to have very task-based. I think it could still be phantoms, could still be simulations, but they have to become much more advanced. So they have to capture all the details that you mentioned earlier, like not spherical.
I guess, yeah, I assumed that iterative recon could not be done without more advanced methods either, or even basic. With that, so I guess you're saying, agreeing with me almost, to saying, yeah, we need a better way of doing it, better techniques, whatever.
Let me also point out that the argument that you can only use a real human anatomy to validate because AI can only train on real human anatomy, I don't think that holds that I don't believe that holds water. People have pacemakers, people have stents, people have all kinds of geometric objects inserted into their bodies that also have to be reproduced by a CT scanner. So I think the answer lies in between. I think AI is going to have to be validated again, back to what Raul was saying, and I was also saying that we're going to use multiple tools, which would be again, clinical data, 3D printing, simulation, gathering view data and augmenting it, things like that, like Bruno showed and many others have shown in the past. So anyway, that's my point of view. Do we want to say anything more about this second one? We got about 20 minutes left.
I mean, just so we have three axes. One is clinical, one is phantoms, one is simulations. I think what we heard today was the phantoms need to get more advanced, like you showed, Rick, and the simulations need to get more advanced, like some of the stuff that I showed. So I think that's where the big advances might be. Not that the clinical is less important, but I think there's a lot of advances possible in the other two axes.
I think it's super exciting that you released your highly advanced. Is that a Monte Carlo simulation or what is it?
No, most of it is ray tracing. There's
okay.
Yeah.
Okay.
So we have some Monte Carlo pieces, but anyway, that's.
Anyway, you open sourced that, and we've open sourced lesion sizing tools and other things, and we're going to make more and more things openly available soon too with other projects. So there's a potential for really helping each other out with these data sets and these resources.
Yep.
There's also there's kind of pure simulation, right, where you create a geometric object and you run it through a virtual scanner and you get out images, right? But there's also augmented data, right?
Yeah, we call it hybrid data simulations, which is taking clinical background images but then inserting artificial features on top of it that you handcraft and you can create nodules with speculations and different textures and things like that. So
but we can set up a working group potentially.
So like Duke has already a lot of progress in this area also, where they have a lot of very good virtual tumors and stuff like that. So.
Yes, I'm aware. But how do you guys feel about establishing a working group on AI CT reconstruction? Let's say just validating it.
what's generally the plan for each of these bullets? Like the first bullet, how would that be obtained? Would it just a recommendation to the public, or?
Yeah, so this is a very general. This first one's a very general recommendation.
Like the first hyper bullet.
Oh, this one?
Yeah. Who would do that?
We don't have to assign anybody to do it. We can just say it's important that this gets done. But since we already have a working group developing protocols, again, you're more than welcome to join, Bruno, if you'd like to be part of that. It will result in a publication, so that's one benefit anyway. And Raul's already on that group. But we could set up another working group, the second one down. So we don't have the ability to assign work to people, even though it would be really nice. So we just put the recommendation out there. But being responsible citizens as we are, we try to achieve the recommendation in the coming year. We don't always succeed, by the way. We had a goal to do some photon counting experiments in this last year, but we didn't get to those. So we're backed up on that one anyway. But how do you guys feel about these first two as recommendations?
Yep, looks good.
Let's say we'll leverage existing lung cancer screen and emphysema group. And we don't need all that underlining. Okay. So then, unless somebody has another topic that we did discuss this potential setup meetings to establish some international regulatory standards for software, let's say software requirements on input image data. So right now, each vendor just either has no requirement, they just take any data and they'll try and segment it and give an answer and won't say a word. They'll just give a number out if they try and calculate a volume of something. But the idea here is that what if we were to say, hey, software really should have a statement saying what is the quality of the image data coming in that this software is designed to work with. And if it's outside of that range, it really shouldn't attempt to do the measurement, or at least put warnings on the measurement. It's just trying to get some sanity around how software operates in the clinical measurement space.
How does this differ from FDA approval or whatever country approval?
This would fold into future requirements for FDA approval. But the question is, could we meet now and try to put some bounds on it and some requirements around it so that, we could go the whole 9 yards and say all software has to give confidence intervals around their measurements, but that's not going to happen, right? Because if they took in bad data, they would have really lousy confidence intervals, right? Not that a clinician would really know what to do with that. So, how do you guys feel about this? Is this something a bridge too far? Is this? Do you guys agree? What do you think?
Well, I think this is going to be tricky, very tricky, I think.
Yeah.
And also maybe we can take as a paradigm how, you know, other devices work, not thinking in the diagnostic space, not how they get regulated, how they get certified. In the, you know, in thinking of the laboratory spectrum, knowing how we can treat imaging under the same, not under the same umbrella. And I think, you know, I feel there is sort of a, if you prescribe a lot the requirements, I guess there is sort of a, that I think is what is happening to some degree underneath, no? I mean, I feel the way things, the software as a medical device for imaging applications get certified today, typically every vendor submit their application with a very concrete protocol. And then somehow that is not even, sometimes it's not even very clearly reflected. And then I think everybody can use, quote unquote, that off label. And that is, I totally agree, that is sort of a gray zone.
Well, it's a, you can drive a Mack truck through that gray zone.
You can, no, you can. And I think that is, I mean, but more than a regulatory standard, I think to me falls under, you know, best practices, not to basically either qualify that protocol and have a quality control of that protocol for which the software has been certified or has been analyzed. I'm thinking specifically on, and we all know now with AI-based devices, no, you know, people use given databases to train their software on, and you know that could be qualified, or they use even specific databases to validate the data on. So that could be, to me, a clear example on saying, look, there is obviously, you have to define or provide a QA approach to verify that the data was, I mean, the data that is being input falls within the validation scope, no? And that is, I think, there is even within the deep learning domain or the community, there is a lot of emphasis in sampling from the same distribution from which this method was trained on. So I think empowering this kind of self-verification approaches, I think to me are you know, a recommendation or a way to go. The other access to this, and you know, I go back to maybe my prior point, is to some degree at which level there is obviously the opportunity to work towards a harmonization space, no? And I think that is how we do things now, no? We are prescribing protocols, but we could go further, no? I think that's sort of I think that could fall. I mean, is that a regulatory standard, or is that just best practices that we think are important to follow? I think still from a regulatory standpoint, I think it's a lot to ask, no? I mean, I think vendors will still qualify their products in concrete scenarios. They will get a certification for those, and any use outside of that scenario, I think to me, is the standard off-label use that we see very often. The thing is, do we want to put safeguards around when you are in the off-label space and what it means? I think it's important, but I wouldn't per se bring it under the regulatory umbrella. No, that could, to me, I think will prevent, really will make things worse. No more. I don't know if it will make more harm than benefit, to be honest.
Well, that can be discussed. This is only to meet.
If you raise the bar, yeah.
This is not to force a standard, a regulatory standard. This is to meet.
Yeah.
But
you know, that is, I mean, but it's a regulatory standard versus best practices or guidelines, no? As the
yeah, but okay, I've been around for close to 30 years. When we give guidelines and suggest, it has from 0 to a small impact. If we were successful in setting a reasonable standard, like if you're going to try and measure a 5 millimeter lung nodule, you should not be using 5mm slice thickness. Okay, it's just we're. I'm giving you like an extreme example, but you could also argue you can't use 2.5mm slice thickness either. And the number of people who are trying to do that around the world right now is staggering. I mean, it's just unbelievable. So, I think we have to go beyond. I mean, we already have a guideline and a publication up at the top, right? Here's what your protocol should do. Here's the things you should do. And that's great. And we're going to get that out there. But when it comes to sorry?
I was thinking, other than providing limits on that first thing to say, so 5mm slice thickness would not be acceptable. I can't quite see how it differs with what you have below, in the sense that I'm a little puzzled what it is that you would arrive at as a regulatory standard there.
It would be basically making a requirement that if you're going to get regulatory approval of a piece of software to do a measurement of a, let's say,
doing a measurement, okay.
Yeah. You need to define what is allowable to come in. Now, I think vendors are doing that to some extent. Some vendors do, but it's hit or miss. Some vendors just they'll just measure anything you throw at the software. They don't care.
So it's going to have a validation mechanism too, then.
Well, that's already required by regulatory bodies. This is just saying there's going to be an extra gate, which should have been there all along, right? Nobody should be making software that will take anything and give you the illusion of an answer, a reasonable answer. Bruno wouldn't allow a CT reconstruction to occur if the view data was completely garbage, right? I mean, you have your standards, right, Bruno?
Yeah, I can see what you mean.
But you're not thrilled with probably a regulatory slant to that.
I am to have a clear vision as to what it would be, how it would be different from the guidelines, and but the first bullet is for the imaging protocol. This is for analytic software.
Yep.
And hard to regulate at this point, but
I don't think it's really that hard. The guideline, the entrance criteria can be quite large. It just can't be infinite.
But I mean, one other way to look at this is if you have the number one, the first bullet implemented, then any software should be validated to work for any images that satisfy in the first bullet.
But there's no requirement that they do, right?
Well, if FDA, that's up to FDA, right?
Yeah.
The FDA, yeah. So the last bullet could make the case for that.
Yeah.
Yeah.
It could say that's the standard that you should use.
Yeah, but do you think the FDA usually doesn't get into there? No, because you are it's the equivalent of you defining or standardizing the predicates. That is hard. No, I mean each vendor based on the specific use case is free to use the predicates, and then they have to meet those expectations. No,
that's how we don't advance.
No, I agree. No, I mean I agree, but we don't advance because then there is very lousy controls on that predicates on what the software was tested on, and I agree. Do you then need? I mean, can we? Should companies be entitled to use their predicate, to use a superior predicate. I agree. Should the agencies impose that? I think that could also be damaging, because there is many different, I mean, there is many different scenarios. No, you as a vendor.
This doesn't say that how the requirement is imposed. It only says that there needs to be a requirement for each piece of software. Maybe the vendor itself provides the requirement, and they make it so wide that it's almost meaningless.
No, and I agree on that. No, and I think the requirement to me is those. I mean, to me, one requirement, and maybe I'm speaking with the bias that as we see the trend, the amount of devices, image, software as medical device, being being regulated today are mostly all based on AI. No, a large proportion is happening that way.
Well, it's heading in that direction, but most of it is traditional image processing.
Well, I mean, the statistics I read lately, I mean, I think this year, 2023, there has been around almost 600 software as a medical device in the imaging.
What's the denominator?
I don't know. Yeah, sorry. I
That's
don't
my
know.
point. My point is the denominator is quite large.
Yeah. Yeah. No, but I think, just to finalize that thought, I think with that emerging trend, and I think we are all acknowledge, no, this is probably an emerging trend. It is, I think the landscape is changing, and it's probably very difficult. I mean, not difficult. I think it's not like the common approach, no, where you used to have, a few images in which you verify your metric. I think now these images, if any, the most you can say is, look, is your software, is the input imaging that you are putting into the software comes from the same distribution was trained on. So if you ask me, yeah, that could be something that there is sort of a standard around the best practices of providing guidance of, are you within label or out of label use? Because that could modify how you read, interpret, use that device. I'm giving a very concrete example in which we can obviously start thinking about these standards, no? The other way around is, yeah, let's harmonize everything, and then let's force every vendor to use this joint common reconstruction, no? For which we all
that's never worked. No, I've never seen anybody force anybody to do anything.
No, exactly. So you cannot go to that extreme. I think the question is, what is the good in intermediate, no? And I don't think you can also impose a standard, because I think that could be very topic dependent. Obviously, if we are talking about nodule sizing, yes, maybe you can develop. I mean, to me, the in-between is forcing the quote unquote the imaging vendors or the software vendors to provide assurances that input data falls within the param is kind of a self-quality control that now is lacking. No, the FDA doesn't require that.
Again, Raul, we're not trying to solve this. We're saying we have a problem, and we just need to meet to discuss it and figure out what the specific solution is, right?
Yeah. No, maybe what I'm pushing back is in international guidelines rather than regulatory standards. I think guidelines might lead into regulatory standards if they prove solid, reproducible, and that people will abide, after there is enough consensus, But I think, to me,
we're already doing that. This first one is already doing what you just said. We're making guidelines constantly. So this takes it a step further and say we really need
guidelines on the imaging protocol, not on the measurement, on the requirements of the measurement software.
No, this is the imaging protocol that's used by this one here is on the imaging protocol going into the software. That's all it is. It's not talking about what the software does at all. Okay, we're out of time, unfortunately. So why don't I try and put some better wording around all of this? I'll email it out tonight, and we'll have one more shot tomorrow during the day, I think, to clean this up. If you feel strongly that one of these is not right or whatever, then we can meet in breaks and try to discuss potentially removing it. Okay, but give me a chance to write some more words around this. Okay, is that fair?
Yes.
All right, guys. Well, we got some recommendations. I don't know if they're earth shattering, but I think they're pretty good. I better well, I better save them before they disappear. Okay. All right, guys. Thanks so much. Take care. Have a great evening.
Thank you. Likewise.
Bye.